You know, when you grab that milk carton from the fridge, have you ever really stopped to think about the journey it took to get there? It looks so simple, right? But what's hiding inside that everyday object is this incredible story, a story of speed, safety, and some seriously brilliant engineering. So let's dig into the big problem they had to solve first.
I mean, that's the real question, isn't it? We're not just talking about a little bit of milk here and there. We're talking about millions and millions of gallons every single day. And every last drop has to be totally safe for you to drink. So how on earth do they pull that off?
Okay, so the answer has to do with something you've probably heard of, pasteurization. It's all about heating and cooling the milk just right to get rid of any nasty bacteria. But here's the thing, not all pasteurization is the same. There's the slow, old-school way, and then there's the super-fast, modern way that changed absolutely everything.
And just look at the difference here. The old way, a full half hour, 30 minutes. But the new way, what we call high-temperature short time, or HTST, does the exact same job in, wait for it, 16 seconds. Just 16 seconds. That's just mind-blowing. And that incredible speed is the only reason we can process milk on the massive scale we do today.
So how is that even possible? How do you get this done so fast? Well, it all happens inside this one amazing piece of gear that's really the heart and soul of any modern dairy. It's called the plate heat exchanger. Let's follow one little drop of milk on its wild ride through this thing.
Okay, to get your head around this, think about a giant stack of really thin steel pancakes, all pressed together. Now the milk flows through one set of channels, and on the other side of that thin steel plate, hot water is flowing. They never ever touch, but that heat just zips right through the steel, from the water to the milk. It's an incredibly efficient way to exchange heat without ever mixing the liquids.
So that drop of milk goes on this crazy 5-step journey. First, it gets pre-warmed. Then it hits the heating section to get up to temperature. After that, it travels through a special tube for exactly 16 seconds. Then it comes back to give its heat away. We'll get to that. And finally, it gets chilled down for storage. Now, it sounds kind of straightforward, right? But hidden in this process are 2 steps that are just pure genius.
All right, so the milk has been heated up and has just finished its 16-second hold time. Now it arrives at what is, without a doubt, the most critical checkpoint of the whole system. This is where we see the first piece of absolute genius engineering, the part that makes sure, with no exceptions, that every single drop is safe.
This amazing little device is called the flow diversion valve, or FDV for short. And you can just think of it like the world's most reliable bouncer at a club. It has one and only one job: check the temperature of the milk coming out of that holding tube and make a simple yes or no decision.
So a sensor checks the temperature. If it's 71.5 degrees Celsius or hotter, perfect. The valve stays open in what's called forward flow. The milk is good to go, it's safe, and it continues on its way to get cooled down.
But what happens if it's not hot enough, even by a tiny fraction of a degree? This is where the magic happens. The valve instantly snaps shut and redirects the flow. That milk gets sent all the way back to the beginning of the line to get reheated properly. No exceptions. Nothing gets by this guard. Ever.
And here's the absolute best part, the real genius of it. The whole thing is designed to be fail-safe. Think about this. The valve actually needs electricity to stay in the go-ahead-you're-safe position. So what happens if the power goes out, or if anything at all breaks? It automatically springs back to the divert position. It's physically impossible for unsafe milk to sneak through, even if the whole plant loses power. How smart is that?
Okay, so we've got safety completely locked down. That's job number 1. But that's only half the puzzle, right? Heating up all that milk, we're talking thousands and thousands of gallons, takes a ton of energy. And that costs money. This brings us to the second bit of pure magic in this system, a little something called regeneration.
Remember how the milk got pre-warmed at the beginning and then cooled down near the end? Well, check this out. The system is so clever, it runs the hot, already pasteurized milk right past the cold, raw milk coming in. And through those thin steel plates, the hot milk gives away its heat to the cold milk. It's basically using the hot milk to do most of the work of heating up the cold milk for free.
So just how much energy does this little trick save? The number is, honestly, it's pretty incredible. Take a look. 80%. Let that sink in. 80% of the energy you need to heat the milk is just recycled from the milk that's already been heated.
That means the plant only has to pay for the last 20% of the energy. That's a huge savings, and frankly, it's what makes this whole operation affordable and keeps the price of milk down.
Okay, so let's put it all together. We've got this insane race against the clock, this unbeatable automatic safety guard, and this amazing energy-saving trick. So what does all that mean for you when you're just grabbing milk for your cereal?
Well, it really comes down to these three things. First, speed. It lets us make enough milk for everyone. Second, safety. That fail-safe valve means you never have to worry. And third, savings. That 80% energy trick is what makes milk something we can all afford.
It's this beautiful, intricate dance of speed, safety, and efficiency all happening behind the scenes. So yeah, the next time you open that carton, you can appreciate the incredible engineering that turned a simple farm product into something so safe and reliable that it's in almost every fridge in the country.
And it kind of makes you wonder, right? What other totally normal, everyday things are hiding this kind of genius engineering? Something to chew on.